Today we're going to be looking at ordered pairs and graphing linear equations. Now this video is going to be longer than they have been in the past, and that is just because my students from last year came in very unprepared for this. So we'll review it a little longer than we have the other areas that we've looked at so far. So first of all, we're just going to take a brief overview of the coordinate plane in general. Here is our coordinate plane, and as you can see, we have an x-axis and a y-axis. Okay, do not get those mixed up. If you get those mixed up, everything you're going to do is wrong. Okay, and then within that coordinate plane, we have some quadrants. We have quadrant 1. In quadrant 1, our x-coordinate and our y-coordinate are both positive. Okay. Then we have quadrant 2. In quadrant 2, the x-coordinate is negative, the y-coordinate is positive. In quadrant 3, both coordinates are negative. And then in quadrant 4, the x-coordinate is positive, the y-coordinate is negative. Okay? So those are our quadrants, and then what our coordinates are going to look like in each one. And I know I didn't specifically state this, but our coordinates are always in xy form. So the x value is always the first value. So let's go ahead and see if we can graph some of these coordinates. So let's look at the first one. A is at -2, 3. So our x is first. So I'm going to go on the x-axis, -1, -2. And then it says I go up 3. So I'm going to go up 1, 2, 3. So that my point A will be where those two meet. So that is point A. Okay. Now let's look at the next one. Point B, -2, -4. So again, we're going to go back -1, 2, and then down -4. 1, 2, 3, 4. So this will be point B. Alright, now I'm not going to show you the steps with this one, just so you can plainly see what your coordinate's going to look like. We're going to look at C. C is at 3, 0. Again, this 3, that is our x-coordinate. So we go over 3, then we go up 0. So that is just our coordinate C. We do not go up at all. And then our last one is 0, -3. So on this one, we don't go over at all for our x-coordinate, but we go down 3. So that coordinate will be right here. And again, I know that this is common knowledge to most of you, but it's very important that we do overview that a little bit. Alright, moving on. Now we're going to get into some linear equations. So what exactly is a linear equation? Well, the linear equation is just an equation of a line. Okay? So I'm going to show you a few examples of a linear equation and then a few examples of nonlinear equations. Alright, so some examples. Let's think of one. Y equals -2x plus 6. That is a linear equation. 3x minus 5y equals 10. That is another linear equation. Y plus 5 equals 2/3 x minus 2. That is another linear equation. Y equals 0. That is a linear equation. X equals -3/2. That is another linear equation. Notice in each one of these equations, we have an exponent of 1. So this is y to the 1, x to the 1, in every single one of them. Okay? You don't have anything squared. You don't have anything cubed. Now let's look at some non-examples. X squared equals 4. That is a non-linear equation. Okay? X squared plus 2y equals 14. That is non-linear. Okay? We have squared values going on here. So with our linear equations, we're not going to have anything squared. We will only have powers of 1. Okay? Alright, so let's look at some different forms of linear equations. We have 3 forms that we see the most. Those are the standard form, slope-intercept, and point-slope. So the standard form, let's look at that one first. That is ax plus by equals c. Okay, here a, b, and c are just variables. Alright, they represent some numbers, and in the actual equation, you will have values there. Okay. Alright, so let's look at the next one. The next one is slope-intercept. This is by far the most common one, the one that you will see over and over and over again. Okay, so slope-intercept form is y equals mx plus b. Okay, here we need to know a few things. First of all, m is the slope of our line, and b is the y-intercept. And again, this is the one we are going to see and look at the most. And then the last one is point-slope form. Now, point-slope form we do not use a lot, but we will use it a little bit, so I want you to be familiar with it. And the equation for that is y minus y1 equals m times x minus x1. Okay? Here, m is still slope, and x1, y1 represents some point on our line. So that's just a point on the line. Okay. So just so you can see an example of each, I'll go ahead and fill that in below each one. An example of standard would be like 2x plus 5y equals 14. That is a standard equation, linear form. Okay. Slope-intercept. Slope-intercept may look like y equals negative 8/5 minus 2. X minus 2, sorry. So that is a slope-intercept equation. It is a line. You can graph it. And then the last one, point-slope, an example of that would be like y plus 2 equals 4/5 x minus 3. Okay, that is a line in point-slope form. So now let's go ahead and get into graphing some of those. So we're going to look at slope-intercept form first, again, just because it's the one that we use the most. Alright, so we're going to graph the equation y equals 2/3 x plus 1. So again, this is slope-intercept form, y equals mx plus b. M is our slope, b is our y-intercept. So here our slope is 2/3 and our b is 1. Okay? Now, when you are graphing these and they are in slope-intercept form, the first thing you want to do is graph your y-intercept. Okay? What that y-intercept is it's where your line crosses the y-axis. So our line here crosses the y-axis at 1. Okay? So here I've already graphed the y-intercept. Now I'm just going to use the slope to determine some more points on my line. Now, slope is rise over run. I'm sure that you have heard that before. It tells you how much your line tilts. Okay? So our slope for this one is 2/3. So that means that our line rises 2 and then it goes over 3. Alright? So if we're wanting to graph that line, we need to go up 1, 2, over 1, 2, 3. So this will be another point on our line. And sometimes it's good just to do a few, so I'll do one more point on our line. I'm actually going to do this one using 2 negatives, a -2 and a -3. But we know that -2 over -3 just equals +2/3. Okay, so I'm just going to use that. So if we go down negative 1, 2 over negative 1, 2, 3, then this represents another point on our line. And now I can connect that and I can have my line. So if I connect those 3 points, there is my line. Alright, we're going to put arrows at the end because lines are infinite. They go on forever, which we'll look at in the next chapter some more. Okay, let's look at the next example. This is another one in slope-intercept form. We just want to look at this one because it's slightly different. Look at your slope in this one. Our slope here is negative 6. We don't have a rise and a run, okay? Or not a clear one anyway. But if you remember, think way back to algebra, a whole number is always over 1, okay? Negative 6 is the same thing as negative 6 over 1. Alright? So here our slope is actually negative 6 over 1. Our y-intercept is negative 3. So again, we're going to graph that y-intercept first. We're going to go down negative 3, make a point. That is our y-intercept. Now we're going to use our slope to determine another point. Okay, so again, our slope is negative 6 over 1. If you notice on this graph, I can't go down negative 6. It will not fit on the graph that I have. If I had a bigger graph, I could do that, but I don't have enough room here. So just like we did earlier, instead of saying negative 6 over 1, we're going to say 6 over negative 1. They are the exact same number. Plug them in your calculator, you get negative 6 either way. Okay? So we're actually going to go up 6, 1, 2, 3, 4, 5, 6, and then over a negative 1. A negative 1, and that is another point on our line. Here I only have enough room to do 2 points, which is enough, so I just need to connect these. Okay, draw arrows on the end, and then there is my line. Alright. Okay, so this is the last one we're going to look at together in an example. This one is in standard form. If you remember looking back at your notes or looking back a few slides, standard form was AX plus BY equals C. So you can see here that A is 4, B is 7, and C is negative 14. Okay, so we've got all that going on. To graph standard form equations, the best way to do it is to get it into slope-intercept form. So how do we do that? We want to get it into slope-intercept. So in order to do that, we need to solve for y. So to do this, solve for y. Okay, so let's go ahead and look at that. And again, this is just a multi-step equation. So I'm going to rewrite it down here. 4x plus 7y equals negative 14. And we're just going to go ahead and start solving this. So we want to get y by itself, so we need to subtract 4x from each side. So we have 7y equals negative 14 minus 4x. Now we need to get y completely alone, so divide by 7. So these cancel, and I get y equals negative 14 divided by 7 is negative 2 minus 4 over 7 x. Okay, and to get it completely in slope-intercept form, we need to trade these two positions. So y equals negative 4 over 7 x minus 2. Okay, so now it's in slope-intercept form. So that's really the only extra step we have with these standard form ones, is we have to first get them into slope-intercept. So our y-intercept here is negative 2. So we're going to go over and plot negative 2. And our slope is negative 4 over 7. So we're going to go down negative 4 and then over positive 7. We're not going to have enough room to do this, unfortunately, but just imagine with me, okay? So we're going to go down negative 1, 2, 3, and then 4, so that would be about right here. and then over positive 7. So that would be, let's see, 1, 2, 3, 4, 5. We need 2 more little boxes, 6, 7. So we'll say that's about right here. Make our point, and then connect those 2 dots. Sorry about running out of room on this one. Next time I'll choose examples where I have enough room to do it. Okay, but that is about what that line would look like. Okay, so now what I want you to do is try these 2. And again, I'm sorry this video is running so long, but it really is important stuff. So what I'm going to do is I'm going to pause this. It will only look like a few seconds on the video, so I want you to also pause the video, try these yourself, and then hit play when you're ready to see the answers. Okay? And go. Okay, so here are the answers to those 2 problems and the work I needed to complete them. So I hope that's good for linear equations. If you have questions, come in class prepared tomorrow and we will discuss those. Bye!